Hi everyone, welcome back. In this week's videos, we're going to talk about two main topics, layouts and behaviors. We're going to continue to build our generative drawing machine framework that we started a couple weeks back, and we're going to just keep expanding on it. As we do, we're also going to do a little bit of housekeeping on the code, talk about restructuring things and so forth. So in this first lesson, this first part here, we're going to talk about layout. Now, here's what I mean by that. So as a starting point here, I've made a copy of the week 4's final example. If you haven't watched week 4 yet, you might want to go back and do that first. I simply duplicated that sketch, and we're going to use that as a starting point. Okay? And what we had, just to remind you, is we had a Perlin noise field, right? So we have some Perlin vectors. And we have some agents that are moving in this field, and their motion is being affected by the Perlin noise field. Last week we explored textures, and now we're drawing the agents as these little sort of tendrils, but we can also draw them as anything. Now, what we're going to be exploring, and we also have a few keyboard shortcuts. So sometimes if you're wondering, you can't see my keyboard, but I have the P key is going to allow me to pause. And if I hit spacebar, it just erases the background. Okay, so I can delete things. I can just erase. We have some interface controls over here. So what do I mean by layout? Well, when I first started the sketch, if we go into setup here, all our agents are created at the center of the sketch. So everything is just emanating from the center. That's a layout strategy. In addition to playing with the behaviors of our agents in a generative drawing machine, one of the main ways that we can kind of impact the overall structure of the drawing is thinking about where these agents are going to begin in the canvas, right, in the window. It could be that they all emanate from the center. That could be a good layout strategy. But we might want to explore like other alternatives. For instance, what if the agents, were created along a circle, perhaps, right? What kind of outcome would we get from that? Let's turn down the life here a little bit. What if agents only just kind of came at us from the bottom, perhaps, or maybe came at us in rows, right? What kinds of structures would emerge from this? It's still the same simulation, but where our agents start is a great way to shape the final outcome, and just another thing that we can play with. So we're going to explore in this lesson one easy way that's very flexible to sort of introduce a variety of different layout options. We could use mathematical formulas, right? So right now I'm creating agents either based on my mouse coordinate or the center of the sketch, right? So for example, if I needed agents to start along a circle, we could whip out our good old trigonometry formulas and calculate points around the circle, and that could give me some starting conditions. So that's a perfectly fine way to do this. I'm going to show you a bit of a hack, a bit of a shortcut to creating different layouts, including any shape that we might want to create. We're going to use an image, basically, that's going to act as a template for where our agents are allowed to start or not. Okay? And we'll get to that in a second. But before we dive into the layout, I just want to take a minute here to start with a little bit of housekeeping in this program, because we've been evolving this sketch for a few weeks now. We're saving different versions along the way, but we are going to just drop a few things from here because eventually this code is starting to get quite long. And one thing that we're going to drop here is the idea of using an image as the color palette. We're just going to stick to an array of colors here. So going to keep the same palette for now. We explored last week that we could also use an image as a source of colors. We're just going to take that out of the program for now, just to declutter a little bit. So I'm going to go through. I'm going to keep preload because we're going to use it in a second to bring in our template for the layout. And as I go, I'm also going to start to introduce these little dividers here, because our sketch is starting to get long, and I find that when the code starts to get longer, short of just moving to straight up a more powerful editor, something like VS Code, which we might cover in class in a few weeks, working in the context of the P5 web editor, I find it helpful to have some visual guides to help me delimitate when I'm scrolling where a function ends, where a function begins. Just kind of give me some visual cues. And because our program is getting long, we're going to also throw some of these in. So we're no longer going to need this image. So I'm going to delete that. And let's see. We will leave this. Oh, this comment is getting a little redundant. So it's always a good idea to once in a while, as you're developing, right? Your program grows organically, you're experimenting, you're trying things. Just kind of take a step back and see, okay, what could I tidy up a little bit? What could we, again, add some lines here. So see, already it's a bit easier to scroll through, right? Are there things that I can just park, put into some other program, just save it for later? Am I really using all of these features? Just to kind of help you not get too lost in your code eventually, right? So for example, I don't think we're really making use of this thickness here, but we might come back and get rid of it. So we will stick to getting colors from our palette here. So I'm going to delete this over here. This little nudge we're applying to our objects, this is also a little bit of a behavior. At some point, we might put that into its own function, but for now, we'll just leave it. We still need apply force, of course. This is our basic movement code, and I'm also going to get rid of some of the additional, extra white space that might kind of hamper readability. Right? We have our main render function over here. And then for simplicity here in this week's examples, even though the tendrils were kind of cool, we are going to stick with more straightforward shapes for rendering. We're going to stick with our lines here, and we're going to kind of go back and forth between the squares or the rotated shapes, the point, and the line. So tendrils, you were awesome, but we will retire you for now. You can always go back to the previous example if you want to revisit some of those ideas. Okay. All right. Just deleting some stuff. And over here, we have our keyboard controls. Okay. So already this code is a little bit easier to navigate. We're also maybe going to get rid of some of the texturing ideas because I'm not going to be using this moving forward in the examples. Now I'm noticing one thing that we could do better here is if we want to play with alpha values, right, which is a great way to experiment with textures. In each of our rendering functions, we have something setting the stroke color, sometimes with alpha, sometimes not. So why don't we just create a separate function that's going to simply just, or maybe at the start of the render, right? We're going to apply the stroke color here. Just do it in one place. And that's going to simplify the subsequent drawing options. So let's cut that out. We are going to apply the stroke color. We're going to set an alpha value, which we're going to add as a setting in 1 second, set the stroke, and then we're going to do our different render options. And now render line is much more straightforward. Now we don't have to worry about setting the stroke here or setting the stroke color over here. Right. Once in a while, just hit play, make sure you're still on track. So now we have the transparency, which is a cool effect we're going to keep that we want to play with. And by the way, just a reason why I'm doing this in 3 lines here is because the agent.color that we created on our agent is simply a string, right? So we're drawing from our color palette over here. We're simply setting it as a string. And if we want to change the alpha value, we have to first convert that into a P5 color object. We can set the alpha value, and then we can set the stroke to that particular color. One other thing that we could do here, maybe that might be smarter, is we could maybe create the color up here. Create the color in create agent, like so. And then we don't have to do it every time here in this context. So maybe we'll do that instead. So now we can say agent.color.set alpha and set the agent.color. I think that's a little clearer, a little better. We're going to have always the same color, but we're just going to change the alpha based on the control we're about to add. Okay, let's go all the way to the top. We are going to add a new setting here. Let's call it alpha. And by default, you just use full alpha, and then we'll have a slider we can play with. And we are going to go into our GUI. We're going to add alpha from the settings object, and that can go, of course, from, let's say, 1 to 255. And then once we've done this, we're going to go back down to render over here. And instead of always using 40, we're going to say settings.alpha. So now we've added another control over here that we can use to play with. And now we can have like transparency, or we can have brightness. Yep. All right, fantastic. Okay, so with that little bit of housekeeping out of the way, we are going to do more housekeeping as we go along, but let's leave it at that for now, because really I want to start talking about layouts. So how would we go about creating objects in specific starting positions, right, following particular patterns, without resorting necessarily to just formulas and equations and things like this? So the technique we're going to use is very straightforward. We're going to bring in some image assets. So I'm going to open a folder here. I've already went ahead and creating a few possible layout ideas. We have a circle. This is just a PNG. It's 1,000 by 1,000 pixels. It's black and white, and I just opened a drawing program and I drew a black circle shape. Okay? The colors don't matter here. As long as you know which color is going to mean what, then you're okay. So in this case, what we're going to do is we're going to bring this image into our program, write a little bit of code that's going to say, find a random position where we have a black pixel in that source image. And this is going to become kind of a mask, a place where we allow our agents to start. Okay? And because this technique is image based, it's very, very flexible. We could make a mask, our mask could be a letter, right? We can start our agents in the shape of anything. It could be a drawing. It could even be some kind of squiggles. Like here, I made a version where they're going to just start along these horizontal lines. I literally just grabbed the paintbrush tool and just hand drawn some shapes here. So it can be super regular and so forth, but it can be hand drawn as well. And you can create these in any drawing program. I'm on Windows. You can use Paint. You can use Pixlr, which is a web-based drawing program. I'm sure you will find something that you can use just to create a black and white image. It could be anything. Here I chose to use square images because our sketch aspect ratio is more or less square-ish in these examples. You could, of course, change the aspect ratio of the image. We're not going to worry too much here about preserving aspect ratio and doing the mapping and those details. I'll leave that for you to figure out if you want to go down that road. For instance, we'll see that once I bring a square circle, if I were to go full screen, it would stretch the image a little bit. So there are ways around that where you can programmatically figure out, how to maintain the square aspect ratio. We're going to keep it simple for this example and just use the image at face value. Okay? So first step, of course, if we're going to use images in our sketch, is we have to upload them. So let's go over here. We have these leftover images from our palettes. So I'm just going to toss these just so they don't clutter up the sketch here. Okay. Also, be a good idea to save once in a while. And let's upload some files. So I'm going to bring in my 3 possible layouts here. And of course, I could have as many as I want. And we're going to upload them. So now I have a circle.png, letter, and lines. Let's start with circle. We are going to create a variable to hold our image. Let's call it layout. And layout equals load image circle.png. And we're going to load that inside a preload just to make sure that the image is ready by the time we open our sketch. Now, this is where we're going to do a bit of a cheat and a shortcut here. At the start of setup, we're simply going to say layout.resize, and we are going to stretch our image to match the window size. Okay, so just be aware of that this is what we're doing. If you are showing your sketch in a different aspect ratio and the layout looks kind of squished or stretched, this is why. So I'm going to assume I have a square layout here. We could just simply create a square canvas if we wanted to keep our lives simple. Or we could do a little bit of math here and then down the road some mapping of coordinates and so forth. But just for simplicity to illustrate the layout idea, we're not going to go there today in this lesson, but I'm sure you could figure that part out. The other thing we're going to do is that the GUI here, it's kind of like in the way a little bit, I find, as it's getting longer. So one thing that we can do is we can say GUI.close when we run our sketch so that it starts out closed. Okay? And then if we want to dig in there, we can open the controls, but it's going to, by default, just kind of be closed. So we're going to resize our layout to match the size of our window. And then over here, instead of always creating the agent at width over 2 and height over 2, we are going to choose a pixel in the image that is black as our starting point. And we're going to do that randomly, of course. So we could do the code directly over here, but that idea of choosing a position on the image, we're going to represent it as a function. Okay? So let's call this position on image. And this is going to return a vector object that's going to have an XY coordinate on the particular image we want to use. Okay, so let's call that image, and maybe presumably we can provide like different variations on that. This is going to be, in our case, we're going to use it with layout. Okay, but we're putting in a parameter so that we could use the same function on different images if we wanted to. And here's the idea, right? So remember, our image here is black and white. So we're going to say arbitrarily, white pixels, we don't want to start there. Black pixels, yes, I want to start on the black pixel. So the way we're going to do this is first we're going to define a variable. Let's call it the goal. We're going to set that to be a color. This is our goal color, black. And I chose black because it's easy, you know, it's just 0, 0, 0. So you can't really go wrong here. We want to make sure that the colors in our image, that we know exactly what the RGB values are if we choose some other color other than black. But black is really straightforward in this case. So our goal is to find a black pixel. And we're going to simply do this by a brute force trial and error process. Okay? We're going to say, let's create a for loop. And here we're going to set an arbitrary number of repetitions. I'm going to set that number fairly high, let's say like 1,000. I'm just making this up here. We could create a while loop here that would continuously search for a random position until we find a black one, which would be okay. But the danger here is that this, if you have a particular image that, you know, what if your image doesn't have any black in it for some reason, your program could get stuck there, or it could take a really long time if you only have just the one black pixel, and it could generate some annoying outcomes. So here we're going to take the approach, we're going to try 1,000 times, up to 1,000 times to find a black pixel in the image. In practice, it's probably going to take like 5 to 15 tries at most. So I picked a huge number to make sure we're almost going to land on the black pixel eventually. Just know this number is kind of like arbitrary, but it does put an end to the number of attempts we're going to do. And if for some reason the function fails, we're just going to return a 0, 0 vector. Okay? So it's a bit of a fail-safe. I got that idea, by the way, for the layouts, looking at the source for the Hype framework by Joshua Davis. Great project. You should check it out if you're not aware of it. So we're going to say up to 1,000 times. Okay, we're going to try. We're going to first pick a random value based on image.width. And remember, I stretched my image to fill the canvas, so we're guaranteed to land somewhere here within the image. If we didn't do that, we might have to be a little bit more clever about using the map function here to translate between image space and screen space. But we've made them the same here for simplicity. So let's grab a random value, and then let's grab the color that is at that location. We can get that using the image.get function. So if an image.get here, this is like a color picker at a particular location. And what we get out of that function call is an array that has the 4 values, RGB and A. Okay? Now we're going to convert that into a P5 color, just so we can compare apples to apples, because our goal is a color as well. Okay? And then we are going to compare the goal with the color, and if they match, we know we found a safe place to create our agent. Okay? Now there's going to be a little gotcha here, and we're going to come back to it in a second. This is actually not going to work, but we'll talk about why in a minute. But in theory, this would be the logic of what we want to do. So if the color matches our goal, we're going to leave the function, we're going to create a vector using Rx, Ry, because we found a black color. Okay? And if for some reason we get to the end of this for loop and we didn't find anything, we have to return something, so we'll just create a 0, 0 vector. Okay? In practice, that's never going to happen, but we put it there because the alternative, if we had a while loop and it failed, our program would get stuck. It crashes the browser. It's really, really annoying. We just don't want to have that situation. So this is a little safer, and 1000 here pretty much almost guarantees we're eventually going to land on a black pixel. Okay, it's very unlikely we won't. Okay, so now we have a function that will return a XY coordinate based on our template or our mask here. So in setup, instead of creating the agent here using the center of the window, we are going to create the agent based on a position that we calculate. So we'll say position on image. Let's give it our layout image we loaded. And then we are going to say p.x, p.y. So let's hit play. Make sure we didn't screw up anything here. And of course we did. So let's see what images we have. X is not defined. At line 2089, let's take a look. Oh yes, okay, my bad. So here I meant to write Rx and Ry. Of course, these are the randomly generated values. I don't know why I call it R, maybe for random. So that's what I was thinking. That's it. Okay, so all of our pixels are starting at 0, 0. So something's happening here. This is not creating the values that we are hoping for. And that's because of like a really sort of a little obnoxious little thing here. But when you realize what's happening, it'll make sense. So what I'm doing here is I'm saying if C is equal to goal, right? So we know goal is the color black and C is the color we're sampling. So why isn't this if statement working? Really quickly to illustrate this, we are going to break out the console. I'm going to open developer tools. This is different on every browser, but it's here for me. And we're going to open the console app here. The console, I'm just going to bump that up here. When we're in the P5JS editor, if you want to use the console, you have to navigate to the blob here, this element over there. And now we are inside our sketch and we can live type some code. We have access to my settings, for example. So I just want to use this to demonstrate something. We're going to create two colors. We're going to compare them. Let's create a color called C1. And we're going to say the C1 is going to be black. Okay. So we have C1. C1 is a color object. We can see it here. And it's got 0, 0, 0 full alpha. C2, we're going to create black as well. Two identical colors. And C2, we can see, is also an object. They look the same. Okay. Both of them are black. Now, if I compare them in the console and hit enter here, the result is false. Okay? These are not the same. The reason for that is that when we compare objects in JavaScript, the answer we will get, unless something has been done here to make sure otherwise, is that JavaScript will tell us, well, actually, C1 is not the same object as C2, right? It's not wrong. They're different variables. C1 is its own thing. C2 is its own thing. They just happen to both represent the color black, but they are different objects. And this is what the equality sign is testing. We want to be able to compare their content. So one quick way that we can do this is we can convert the object to a string. Object has a toString method. And if we say C1 to string, we get this string over here. That's kind of the text representation of that color. And we can do the same for C2. And now we have two strings, 2 bits of text we can compare. And in JavaScript, if you compare one string to the other, it will return true if the strings match. Okay? So this is what we're going to use to compare our colors. And I wanted to explain it like this because otherwise it can seem a little odd that we are going to a string representation. Why? Again, that's because these two are really different objects. And this is it will always return false if we try to compare them to each other. Now, by converting to a string, we can compare the actual contents and we can know if our colors match. And now we have a layout here where our objects are going to start along a circle. Okay? We can shorten our life a little bit here for our agents, maybe like just so we can see them a little bit better, or see our shape a little bit better, right? So now every time we start to sketch, we are starting into this circle shape. Or we could add like lots more agents, maybe in setup. Let's go to 1,000, right? Just to like really drive the point home here that now we can influence the layout, the starting conditions of our sketch. It's a really, really cool idea. We could switch to a different image, right? I have lines here, and now lines, we get a different layout, right? I could switch to my letter. And at this point, you know, this kind of the sky is the limit here in terms of imagining different ways that, you know, you could create the layout, or maybe we create a lot more friction, right? We can start to play around with these ideas. We can combine the behaviors of our agents and where they start. You could decide, you could have a section in the center where they emanate from, or they can only come from the edges or top and bottom. And any kind of combination is very easy to represent if your starting conditions are simply defined by a mask or a template. So sure, we could use equations for things like circles and maybe even on the line. That can work. That's totally fine. But this is a little bit of a hack and a shortcut to give us some more flexibility and maybe create some unusual shapes. You know, it could be some random squiggles that you make. And this is the starting conditions for your sketch. All right, go back to the circle here. Awesome. Now notice if I press the mouse cursor, right, I still get little dudes here being created where my mouse is. So we're going to leave that in for now, just so we have that option to kind of test around. The annoying thing here is that if I'm playing with the controls, it does tend to spawn some new agents. So as a result, it might be interesting to say when we clear the background, right? I don't want to get those leftovers that were created. So maybe in addition to clearing the background on spacebar, we can also start fresh, just kind of respawn a whole new bunch of agents as we're doing here. So let's implement that. We're going to do just a few more bits of housekeeping here before we move on to part 2 of this week's tutorial. So let's implement this because that would be nice. So let's take that code here. I'm going to put it into a separate function. So we're going to go somewhere, it doesn't matter where. And we're going to create a function. Let's call it spawn agents. I love the word spawn. We are going to cut this and we're going to replace this by spawn agents. And every time we run this code, it's going to simply go in here and add a whole bunch of new agents. Here it's adding them 1,000 at a time. We can even make this a parameter, right? So we could say this is going to be n. When we go spawn agents over here, we could put in 1,000, and maybe down the road, if we want to add a few more, you know, we could reuse that code maybe on a key press or something, maybe with a different number. We can even put a default value here of 1,000 or 100 or something, so that if we call spawn agent without the parameter, we'll get the default value. So now we have spawn agents. Oh, spawn agents with an S, of course. And what we'll do is we're going to use that. In fact, let's use the default value here. Now we're going to get 100. Okay. Let's increase our default to 1,000 just for now. And when we erase the background on spacebar, so this is all the way at the bottom. So we have a key press here on spacebar. We're going to erase the background, and then we'll do something interesting. We're going to delete all the agents at once. This is very easy because all the agents are stored inside our group array. So if we want to start fresh, we're just going to go like this. Replace group with a brand new empty array that has nothing in it. And then we're going to say spawn agents. Okay. So this is going to have the benefit that if we mess around here, every time we press spacebar, we can start fresh. Okay. And if we tweak, you know, the settings here, we're accidentally adding some agents. That's fine, not a problem. Okay. Great. Okay, so we can play around with these settings. And this is a little bit of just a quality of life improvement, right? Let's increase the, oh, I'm just messing around here, really. Let's see what happens, different settings. Okay. And it might be nice to have a key press that will add more agents. So let's put that in. Let's use A for add agents. We'll say spawn more agents, and maybe we'll add them in increments of 100 instead of 1,000. So now if I press A, right, I can go in and I keep adding more of these little guys here. So you get the idea. So our ability to sort of create interesting outcomes with our generative machine often is going to be limited to the controls we give ourselves as the artist, right? So really think about that. How do you set up your interface, right? Because you are creating essentially a custom interface for you, and those elements, those tools that you build, are going to open up pathways or close doors depending on how you structure them. So always think about, if you're trying to do something and something is getting in the way, or like, don't forget you're writing a program from scratch, so you can always just add features as you need them. Okay, not a problem. So now we could say, like, what happens if maybe like I add a ton of these, right, over time. Yeah, so we have these options. All right. One tiny little bit more housekeeping before we actually, we're gonna leave it at that, and then at the start of the next video, we're gonna do also a little bit more housekeeping. We are gonna move away, sadly, from Perla noise, as amazing as it is. In the next video, we're gonna start to talk about a little bit of different strategies we can use now that we have the option to create layouts. Different strategies we could use to create different behaviors. Okay? So Perla noise is a great behavior. It's affecting the shape of our objects as they move. But there's like other things we can do with our agents that are not just always noise based. And we're going to explore that a little bit in the next and last video, sort of covering generative drawing machines. So I'll see you in the next lesson.